What if I told you that right now, as you're listening to this, something from deep space is passing through our solar system, a visitor not bound by the sun's gravity, not born from the planets we know, and not behaving like anything we've ever seen before? For centuries, comets and asteroids have drifted through the night sky, predictable and ordinary, but every once in a while something arrives that rewrites the script entirely. In 2017, it was Oumuamua, a long, thin object that moved like no natural rock should. In 2019, it was Borisov, a comet that looked familiar but carried alien chemistry. Now, in 2025, the cosmos has delivered another intruder, and this one is stranger than both combined. Its name is 3IATLAS, and it is turning science, astronomy, and maybe even our assumptions about intelligent life upside down. At first glance, Atlas looks like a comet, bright, glowing, wrapped in dust. Nothing unusual about that, but the deeper astronomers look, the less sense it makes. Its tail isn't pointing the way it should. Its orbit cuts across the solar system in a retrograde path, threading past Mars, Venus, Earth, and Jupiter, like a cosmic tourist hitting all the major destinations. Its closest approach happens behind the Sun, a place where our telescopes are nearly blind, as though it deliberately chose the one route that would keep its secrets hidden. Some scientists insist it's just an icy rock behaving oddly. Others whisper that the odds of this happening naturally are so small they border on impossible. The truth is, no one knows what 3I really is. But one thing is certain. If someone wanted to send an object into our neighbourhood without drawing attention, they could hardly design a better disguise. And that possibility, the idea that we may be under observation right now, is why this story is more than just astronomy. It's about whether we're ready to recognise what might be staring us in the face. From the moment astronomers began tracing the path of 3I, one fact became impossible to ignore. Its trajectory looks less like an accident of gravity and more like someone carefully aimed it, as though threading a needle from across the galaxy. Objects that wander into our solar system usually follow wide, chaotic paths. They skim the edge of Jupiter's pull, swing through the inner system, or get flung back out into the void with little regard for precision. But 3I didn't stumble in like a drunk wanderer. It sliced across our solar system in a perfect retrograde orbit, moving directly against the flow of every planet, as if announcing its presence by breaking the rules we thought were universal. Imagine standing in a crowded street where everyone is walking the same direction, and suddenly one figure cuts straight against the tide with perfect balance and focus. That's what Atlas looks like. A stranger who doesn't belong, moving with purpose. The retrograde path itself is bizarre enough, but the details make it even more unnerving. The object's alignment brings it past Mars, Venus, Earth, and Jupiter, not too close to crash, not too far to be irrelevant, but at distances that seem engineered to give just the right perspective of each planet. Each flyby acts like a waypoint, the kind of carefully plotted maneuver we use when sending our own spacecraft to explore. When NASA designs a mission, engineers calculate gravity assist to save fuel and maximize observations. They choose paths that allow a probe to sweep past multiple worlds, gathering data as it goes. Now here we are watching Atlas do the same thing, except no human hands plotted its course, at least not any we can admit to. The probability of a random comet just happening to trace such a route is vanishingly small. Scientists have tried to wave it away by pointing to the vast number of comets and asteroids floating in the galaxy, arguing that unlikely paths eventually happen. But this isn't just unlikely, it's surgical. Then there's the timing. Atlas didn't just drift into our view at any moment. It chose, or appears to have chosen, a path that brought it closest to Earth during a window when our telescopes were least equipped to watch. Its perihelion, the point nearest to the Sun, lined up with a period when the object disappeared into the Sun's glare, effectively hiding from our instruments at the exact moment we might have gotten answers. To skeptics, this is coincidence. To those who look deeper, it feels like design, as though whatever sent Atlas knew how our observational blind spots worked and exploited them perfectly. If that's true, then the object didn't just arrive, it maneuvered. Astronomers who first calculated the trajectory called it extraordinary, but were careful not to say more. The language in early reports used phrases like unexpected precision and statistically improbable, but those words barely capture how strange this really is. Think of a dartboard placed on the other side of the room, and imagine throwing a dart blindfolded from across the street and hitting the bullseye. Then imagine doing it not once but 4 times in a row, threading the dart past moving obstacles without ever grazing them. That's the level of improbability we're dealing with. And yet, here it is, flying through space exactly along that path, leaving us to wonder whether it really was just luck, or something else entirely. The odd part is how quickly the scientific establishment tries to downplay this. Some papers suggest gravitational focusing, the idea that massive planets like Jupiter can pull objects into paths that look suspiciously neat. Others talk about selection bias. Since we only notice the strangest visitors, of course their paths look unusual. These explanations sound reasonable on the surface, but they unravel when you push harder. Gravitational focusing can explain minor tweaks, not an orchestrated series of planetary flybys. Selection bias doesn't account for the uncanny precision of the orbit. What they really reveal is our discomfort. We don't like where the evidence points, so we invent narratives that keep us safe inside the box of natural. But the more you examine the trajectory, the harder it becomes to stay in that box. Consider the retrograde orbit again. Almost everything in the solar system, planets, moons, asteroids, moves in the same direction, inherited from the swirling disk of dust that formed the Sun. Retrograde paths are rare because they require an enormous amount of energy to achieve. A comet coming in from the Oort cloud almost never ends up moving against the entire system's flow. For Atlas to do so means it had an incredible kick from somewhere. A push strong enough to reverse the natural order. Random chance can't easily explain that, but design? Suddenly it doesn't look so impossible. Even more curious is the speed. Atlas is moving at nearly 57,000 kilometers per second, a velocity so high it's clear it isn't bound to the Sun. This is no ordinary comet orbiting in an elongated ellipse. This is an interstellar traveller, a body that came from beyond our neighbourhood and will eventually leave it again. To move at that speed, in that direction, along that precise path, feels less like an accident of physics, and more like intention. And if there's intention, then the entire conversation changes, because it means we're not just looking at a rock, we might be looking at a message. What kind of message could a trajectory hold? To us it might look like nothing more than numbers on a chart, but to a civilization capable of sending such an object, the orbit itself could be the signal. By choosing a path that breaks every statistical expectation, that brushes past planets as though to say, yes, we see you, the trajectory becomes communication, not in words or symbols, but in action, a message that says, we're here, we're watching, and we know exactly how to remain just out of reach. For now, scientists continue to calculate, debate, and publish papers that soften the edges of the truth. They admit the orbit is odd, but retreat into language that makes it sound less alarming. That's the psychology of denial at work. But for anyone paying attention, the trajectory of 3I/ATLAS is the first clue that this object is not like the rest. It didn't stumble into our solar system by accident. It arrived like a precision instrument, a cosmic dart aimed straight at the heart of our planetary neighbourhood. And whether it's natural or not, that impossible shot demands we ask the question we've been avoiding since Oumuamua. What if someone is sending these things on purpose? And what if we're already in the middle of a conversation we don't know how to answer? The story of 3I/ATLAS begins not with a thunderclap revelation, but with the quiet hum of data flowing across observatory screens on a crisp night in July 2025. The telescopes of the Atacama Desert, perched high in Chile's thin air where the skies are clearer than almost anywhere else on Earth, picked up something strange, a bright smear of light that did not match any catalogued star, comet or asteroid. At first, it was just a faint dot moving against the static background, nothing unusual to astronomers used to scanning for near-Earth objects and comets. But within hours, the object's speed became impossible to ignore. It wasn't just drifting slowly across the field of view, it was cutting through space at nearly 57,000 kilometers per second. That's the kind of speed that tells you instantly this thing is not from here. It isn't orbiting the Sun, it isn't bound to the solar system, it came from somewhere else, and soon it will be gone again. News spread quickly among astronomers. Within a day, observatories from Hawaii to the Canary Islands were tracking the interloper. The first calculations confirmed it. This was only the third known interstellar object ever seen, following Oumuamua in 2017 and Borisov in 2019. That alone was enough to set pulses racing. The chance of spotting one of these cosmic drifters in a human lifetime is small, and now we had 3 in less than a decade. But the excitement quickly gave way to unease, because the data wasn't lining up with what anyone expected. Normally, comets heat up as they approach the sun, releasing gas and dust that form a trailing tail. With Atlas, the glow appeared ahead of the object, as though light was scattering from some unknown material being pushed forward instead of back. When telescopes tried to analyze the spectrum, looking for signatures of water vapor, carbon monoxide, or other comet gases, they came up mostly empty. The dust was there, yes, but the gas that should have been driving it was strangely absent. Within a week, the mainstream press had picked up the story. Headlines compared it immediately to Oumuamua, the elongated visitor that Harvard astronomer Avi Loeb controversially suggested might have been alien technology. Reporters loved the angle, and the public was once again gripped by the idea that we might not be alone. Social media lit up with conspiracy theories, memes, and speculation, everything from alien probe to planet killer to NASA cover-up. Scientists tried to calm the noise by labeling it a comet. Strange, yes, but still within the realm of natural explanations. But the problem with labeling something a comet is that comets behave predictably, and this one did not. The harder researchers looked, the more questions piled up. One of the first mysteries was its size. Early estimates put Atlas at nearly 20 kilometers across, large enough to dwarf Mount Everest. But as it approached, refinements shrank it down to just a few hundred meters at most. This wasn't unusual by itself. Brightness can be deceptive depending on how reflective an object's surface is, but the drastic change fed suspicions that the object might be hollow or covered in highly reflective dust. Some even speculated that its brightness was being manipulated, either by design or by some exotic material we don't yet understand. For every astronomer who insisted it was just an icy body, another quietly admitted that the anomalies didn't sit right. Meanwhile, ordinary people started pointing telescopes and cameras skyward, eager to catch a glimpse. Amateur astronomers reported strange fluctuations in brightness, as though the object was tumbling in a way that didn't quite match the spin of natural bodies. Some claimed to see flickers, pulses of light that might have been nothing more than observational error, but to others looked suspiciously like signals. No credible observatory confirmed those flickers, but the rumours added fuel to the growing fire of speculation. The official channels were cautious, almost too cautious. NASA and the European Space Agency put out statements acknowledging the discovery, but emphasized over and over again that there was no evidence of artificial origin. To anyone listening closely, that phrase carried a strange weight. Why even mention artificiality unless it was being asked behind the scenes? Why go out of your way to deny something most people wouldn't assume, unless you feared they already suspected? The careful wording made the object sound less like a simple rock, and more like a subject of debate, with scientists themselves split behind closed doors about what exactly they were seeing. And then came the comparison to Oumuamua, which loomed over every conversation like a shadow. Oumuamua had defied expectations by accelerating without a visible tail, sparking debates that still haven't been resolved. Borisov, by contrast, had behaved like a textbook comet, except its chemical makeup suggested it was born around another star. Atlas seemed to straddle both worlds, bright and dusty like Borisov, but puzzling and evasive like Oumuamua. That combination made it harder to dismiss because it didn't fit neatly into any box. If it was a comet like no other. If it was something more, then it was hiding in plain sight, using the disguise of a comet to slip through unnoticed. Scientists who dared to speculate publicly faced pushback, but whispers grew louder in private forums. The trajectory, the brightness, the timing, it all seemed too perfect. One astronomer reportedly said off the record that it looked like a flyby mission, the kind of course you'd expect from a probe sent to study multiple planets without getting caught. Another suggested that its closest approach behind the sun was the smartest possible way to avoid prolonged observation. These comments never made it into official papers, but they circulated widely online, giving skeptics plenty of ammunition to claim that the truth was being buried. But even stripped of speculation, the facts were strange enough to capture attention. Here was an object from beyond the solar system, moving faster than almost anything we'd ever tracked, glowing in a way that defied comet physics, and following a trajectory that looked almost designed. Discovery is usually the moment of clarity, the point where an object is catalogued, named, and filed into the order of the known. With 3IATLAS, discovery was the opposite. The more we learned, the less sense it made. It wasn't clarity we gained in July 2025, it was confusion, the kind that gnaws at you, the kind that makes you wonder if the universe just dropped a puzzle in our lap and is waiting to see if we're sharp enough to solve it. And that's why the discovery of Atlas matters so much. It's not just another rock catalogued and forgotten, it's a question carved into the sky, daring us to look closer, because if this is just a comet, then it's the strangest comet we've ever seen. But if it isn't, then its discovery marks something far bigger. The moment we realised we might not be the only ones charting courses through the stars. When astronomers first confirmed that 3IATLAS was an interstellar visitor, the sense of shock carried with it a familiar chill, because this wasn't the first time humanity had been confronted with something that defied easy explanation. In fact, it was déjà vu, the echo of mysteries still unsolved, the shadow of previous visitors that had slipped through our solar system in recent years. For centuries we believed our skies were ours alone, populated by comets, asteroids, and the predictable dance of planets. Yet beginning in 2017, reality cracked open and showed us that the void beyond the sun is not as silent as we once imagined. That year, a strange traveller entered from deep space and left behind a legacy of unanswered questions. Its name was Oumuamua, and its presence changed everything. Oumuamua was unlike any comet or asteroid ever recorded. Instead of being round or irregular, it was elongated, shaped like a cigar, or perhaps a pancake depending on how the light caught it. Even stranger, as it passed through the inner solar system, it accelerated in a way no one could explain. Normal comets speed up because they vent gas as sunlight warms their icy cores, producing a tail that pushes them forward like a natural rocket. But Oumuamua showed no visible outgassing, no plume of dust or gas to account for its strange behaviour. It simply moved quietly, unnervingly, as though propelled by something invisible. For some scientists, this was just a puzzle to be solved with new models. For others, it was the first clear sign that maybe, just maybe, we were looking at something designed. Harvard astronomer Avi Loeb famously suggested it could be alien technology, perhaps a discarded solar sail drifting through space. His idea was dismissed by many, but the debate revealed just how uneasy the scientific world was. Here was an object that played by rules we didn't recognise, and we were forced to either invent explanations that stretched physics thin, or accept that we might not be alone. 2 years later, in 2019, another visitor appeared. This time, it was a comet named Borisov, and at first glance it looked far more ordinary than Oumuamua. Borisov had the classic tale of dust and gas, the kind of signature comets are supposed to have. But when astronomers studied its chemistry, they found anomalies that marked it as an outsider. Its ratio of gases was unlike anything seen in comets from our own solar system, suggesting it had formed around another star under conditions entirely different from our own. Unlike Oumuamua, Borisov didn't leave us debating whether it was natural or artificial. It was clearly a comet, but it reminded us that interstellar visitors are real, that chunks of other worlds wander into our neighbourhood, carrying with them alien fingerprints etched into their structure. Together, Oumuamua and Borisov were enough to shake astronomy to its core. The idea that we might live in a quiet, isolated solar system was shattered. We now knew with certainty that interstellar objects pass through more often than we thought, and each one brought with it the possibility of answers, or more questions. Some scientists tried to calculate the odds. Were we just lucky to have spotted 2 in such quick succession, or did this mean these visitors were far more common than previously assumed? The math suggested that if we'd seen 2 so quickly, there must be countless more slipping past unnoticed. And if countless more are passing by, then which ones are we missing? Which ones might not be random rocks at all? That question grew sharper with the arrival of 3IATLAS, because while Borisov gave us a comet and Oumuamua gave us a riddle, Atlas seems to combine the strangest parts of both. It glows like a comet, yes, but its behaviour mimics the mysteries of Oumuamua, the strange forward-facing brightness, the puzzling trajectory, the absence of clear gas emissions. To many astronomers, this was like watching history repeat itself with added complications. It was as if the universe, or perhaps something within it, was running an experiment. First give humanity a puzzle, then give them something familiar but foreign, and now deliver a hybrid that blurs the line between natural and intentional. Déjà vu, but deeper, sharper, more unnerving. For the public, the memory of Oumuamua never really faded. It remained lodged in the imagination. The idea that a messenger from another star might have brushed past us without warning. When Atlas appeared, the comparisons were immediate, and people remembered the questions that Oumuamua left behind. Was it truly just a rock, or had we let an alien artifact slip through our fingers? Borisov added weight to the conversation by proving these visitors were real and repeatable. Atlas then arrived like the next chapter in a story we hadn't finished reading, a sequel that suggests the pattern is no coincidence. If visitors have come 3 times in less than a decade, how many times did they come before we had telescopes sharp enough to notice? And how many times will they come again? The unsettling part of this déjà vu is the sense of escalation. Oumuamua hinted at technology, Borisov hinted at alien chemistry, and Atlas hints at design hidden in disguise. The objects don't just appear, they arrive in sequence, each stranger than the last, as though building toward a conclusion. Maybe it's chance, maybe it's just statistics catching up with our improved observational tools. But for those willing to see patterns, it feels like a message growing louder each time, daring us to stop dismissing and start listening. If the first interstellar visitor was meant to shock us awake, and the second was meant to ground us in reality, then the third seems to be testing whether we can handle the possibility that the truth is both. Real comets exist, but so do things that imitate them for reasons we can't yet grasp. Scientists are careful not to draw those lines too openly, but whispers of them are everywhere. Atlas doesn't just remind us of Oumuamua, it forces us to relive the same arguments, the same denials, the same discomfort. Only this time the excuses are harder to make. How many times can we call something a coincidence before coincidence itself starts to sound like a cover story? Déjà vu has a way of cutting through rationalizations, because when the same mystery appears again and again, you can't simply say it's nothing. You're forced to consider that maybe the universe is repeating itself until you pay attention. That's the weight of Section 3. We've been here before, and yet we've learned so little. Oumuamua left us arguing. Borisov left us staring. Atlas leaves us wondering whether we're missing the point entirely. If each interstellar visitor is a test, then we're sitting in a classroom where the exam questions are repeated in different forms, and every time we answer wrong, the grader just shakes their head and gives us another chance. Déjà vu, yes. But maybe déjà vu with a purpose. Because if the visitors keep coming, it means the lesson isn't over. And maybe, just maybe, the real test isn't about identifying rocks or comets. It's about whether we're willing to admit we've seen this before and recognize that the pattern itself is the message. For all the suspicion swirling around 3IATLAS, one of the reasons it continues to hold the world's attention is because it wears the perfect disguise. If you strip away the strange trajectory, the odd timing, and the unusual brightness, what you're left with, at least on the surface, looks like a comet, and that's precisely why the debate hasn't ended. Because while its orbit and behaviour raise countless red flags, its appearance has just enough of the familiar to lull many into comfort. It glows, it sheds dust, it carries a coma that expands as it approaches the sun, and it trails what looks like a faint tail. All of those features scream comet, and comets are old news. They're the leftovers of the solar system's formation, icy bodies that come alive when sunlight vaporizes their frozen surfaces. We've seen them for centuries. They've been omens in ancient history, studied curiosities in modern astronomy, and now mostly background characters in the cosmic play. To call something a comet is to place it firmly in the category of ordinary, and that's what skeptics cling to with Atlas. The coma is one of the strongest pieces of evidence in favour of natural origin. As Atlas neared the sun, telescopes observed a bright hazy cloud enveloping it, a cloud made of dust and vapour scattering sunlight in all directions. That's textbook comet behaviour. The coma isn't just a glow, it's the signature of outgassing, the process that happens when frozen gases trapped beneath the surface heat up and explode outward, carrying dust with them. Even the forward-facing brightness that puzzled so many could, in theory, be explained by dust scattering in unusual ways, depending on the angle of the sun, the orientation of the object, and the size of the particles released. Dust doesn't always obey neat rules, and in the chaos of sublimation, sometimes strange effects emerge. To scientists who want Atlas to be natural, the coma is comforting. It suggests that despite the oddities, this is still a chunk of ice and rock playing out the same drama comets always do when they wander close to the Sun. Then there's the tail, faint but visible. The tail of a comet forms when solar radiation pushes dust and gas away from the object, creating a trail that can stretch millions of kilometers. With Atlas, the tail wasn't the dramatic streamer seen in bright comets like Hale-Bopp or Neowise, but it was there, just enough to fit the profile. And even though the direction seemed strange, pointing in ways that didn't quite match the physics of solar wind, it still gave skeptics a handhold. If it has a tail, it's a comet. That's the mantra, repeated like a shield against the unnerving implications of everything else. Spectroscopy, too, offered defenders some ammunition. While early observations struggled to find clear gas emissions, later reports hinted at faint signatures of water vapour and other volatiles, just enough to argue that yes, this object was behaving like a comet. The data wasn't clean, the signals weren't strong, but science often works in noise, and the tiniest spike in the spectrum was enough for some researchers to declare victory. There's gas, they said. That means it's natural. And maybe they were right. Maybe the low signals were the result of Atlas being unusually dusty, its gas hidden beneath thick clouds of fine particles. Not every comet is the same, and the variety in their behaviour is vast. To assume Atlas couldn't simply be an oddball among comets is, in itself, a leap. Even the shrinking size estimates can be spun toward natural explanations. When Atlas was first discovered, its brightness suggested it might be enormous, perhaps 20 kilometres across. But as it drew nearer, refinements dropped that estimate to only a few hundred metres. This discrepancy wasn't sinister, skeptics argued, but expected. Comet brightness is deceptive because much of the glow comes not from the nucleus itself but from the dust and gas surrounding it. A small comet with an unusually large or reflective coma can appear far larger than it really is. The shrinking estimates didn't mean Atlas was hollow or artificial. They meant astronomers had been fooled by the cloud around it, a common error in early observations. And then there's the most powerful argument of all, probability. The universe is big, and strange things happen all the time. For every one of the millions of comets in our solar system, there are countless others scattered throughout the galaxy. When you're dealing with numbers that large, even extremely unlikely coincidences eventually occur. An odd orbit here, a weird glow there, it's bound to happen. From this perspective, Atlas is nothing more than the latest in a long line of statistical outliers, a comet that happens to look strange because outliers always do. To leap from anomaly to alien technology is to jump across a canyon without a bridge, and science demands more caution than that. These natural explanations form a net, a safety blanket woven tightly by those who refuse to let their imaginations run unchecked. To them, calling Atlas artificial is lazy. It's giving up on the challenge of understanding physics, of refining models, of stretching human knowledge to fit new puzzles. Every strange detail can be explained, they argue, if you just look hard enough. Dust scattering explains the forward glow. Selection bias explains the improbable trajectory. Shrinking size estimates explain the brightness. Weak gas signals explain the coma. Piece by piece, they stitch together a story that, while messy, is still firmly grounded in the realm of nature. And there is something appealing about this defense. Not because it resolves everything neatly, it doesn't, but because it reminds us that the universe is under no obligation to make sense in simple ways. We have seen comets break apart in sudden violent bursts, like Shoemaker-Levy 9 colliding with Jupiter. We've seen comets flare unpredictably, brightening and dimming without warning. We've even seen comets split in half, leaving trails of debris scattered across the sky. With that kind of chaos, why should Atlas be any different? Why shouldn't it be just another oddball? Another reminder that the cosmos is wilder than we give it credit for. But here's the subtle brilliance in what makes Atlas look natural. The disguise is good enough that you can't dismiss it outright. If it were purely anomalous, lacking a coma, lacking a tail, looking nothing like a comet, suspicion would skyrocket. Instead, it gives us just enough normality to keep the door open for denial. Its behaviour is suspicious, but its appearance is familiar. And in that familiarity lies comfort, the kind that lulls us into dismissing the stranger truths. Whether it's natural or not, Atlas has dressed itself in the perfect mask. the ancient costume of a comet, and as long as it keeps that mask in place, the debate will never end. Because sometimes, the best way to hide is to look exactly like what people expect to see. For all the reasons people cling to the idea that 3I/ATLAS is just another comet, the evidence that makes it look suspicious is far louder and far harder to ignore. The first red flag lies in its brightness, which doesn't behave like a comet's glow should. Normally, the sun heats a comet's surface, vaporizing ice and sending gas and dust trailing behind in a tail that always points away from the sun. It's predictable, almost mechanical. But Atlas refuses to follow the script. Instead of trailing light behind, it shines forward, as though the brightness is being projected ahead of its motion. To explain this away, skeptics talk about dust scattering at unusual angles or complex particle dynamics, but that feels more like a patch than a solution. Because the truth is simple, no natural comet we've studied glows like that. Atlas isn't just reflecting sunlight, it's bending it in a way that seems deliberate, as if something inside is designed to scatter illumination differently than nature would. Then there's the size problem, which grows stranger the more you look at it. When Atlas was first spotted, estimates put its nucleus at nearly 20 kilometers across, a colossal body large enough to make it one of the biggest interstellar visitors ever seen. But as it approached, that number shrank again and again until it was no more than a few hundred meters wide. Now, astronomers will tell you this is normal, that comets often appear brighter than their cores because of dust clouds surrounding them. And yes, that's true. But the magnitude of the adjustment here is staggering. We're not talking about a minor correction. We're talking about an object going from mountain-sized to football field-sized in the space of weeks. Some have argued that the brightness isn't coming from the object at all, but from an unusually large dust shroud being pushed off its surface. Others whisper the possibility no one wants to write in papers. What if the brightness isn't natural at all? What if the glow is an artifact of design, a feature to make it visible when needed and invisible when not, a kind of camouflage or signal controlled rather than accidental? The trajectory makes it worse. Atlas moves through the solar system not like a rock caught in gravity's grip, but like a probe tracing a mission plan. It sweeps past Mars, Venus, Earth and Jupiter at distances that look suspiciously intentional, as though it's collecting data or showing off its precision. And just when we could have studied it most closely, it passes behind the sun, hidden in blinding light where our instruments can't follow. That single fact has gnawed at astronomers since the day its orbit was calculated. The odds of an interstellar object just happening to time its closest pass for a window of maximum obscurity are vanishingly low. Yet here we are watching as Atlas uses the sun itself as a shield, blocking us from prying too deeply. If you were trying to sneak through someone's territory unnoticed, that's exactly how you do it. Another suspicious detail is the lack of gas emissions. While dust has been abundant around Atlas, spectroscopic analysis has failed to detect strong signatures of water vapor or carbon dioxide, gases that should be pouring off an object heated by the sun. Instead, we get faint hints, almost as if the gases are being suppressed or hidden. Some scientists propose that Atlas might be unusually depleted. Its ice is buried beneath a crust that resists sublimation. But even that doesn't quite fit because the dust is still there, streaming out in ways that suggest gas should be present to push it. Imagine smoke without fire or waves without wind. That's what Atlas looks like, and the contradiction unsettles anyone paying attention. And then there's the orientation. Atlas's orbit is retrograde, meaning it moves against the flow of nearly everything else in the solar system. That alone is rare, but add to it the fact that it intersects the planetary plane at just the right points to skim by multiple worlds, and the picture starts to look less like random chance and more like a survey mission. We designed spacecraft to do exactly this, flybys that maximize encounters while minimizing risk. The fact that Atlas mimics this pattern so closely has left more than one astronomer muttering privately that the resemblance is uncanny. Suspicion also grows when you compare Atlas to its predecessors. Oumuamua baffled us by accelerating without visible outgassing. Borisov looked more normal but carried chemistry that made it alien in origin. Now Atlas arrives looking like a comet but carrying all the telltale anomalies. Forward brightness, odd trajectory, lack of gas. It feels like escalation, as though each interstellar visitor is meant to be stranger than the last, forcing us to confront possibilities we'd rather ignore. The déjà vu is undeniable, but it's heavier this time, sharper, as though the stakes have been raised. And that sequence itself looks suspicious. Because nature doesn't arrange objects to teach lessons. Patterns like this don't just happen. They're orchestrated. The amateur astronomers haven't helped calm things down. Many report fluctuations in brightness, as if Atlas is tumbling in a way that doesn't match natural spin. Some even claim to have seen flickers, brief pulses of light that look suspiciously like signals. The mainstream dismisses these reports as noise, the artifacts of imperfect instruments and human error. But once the rumours take root, they feed the narrative. What if Atlas is more than a rock? What if it's transmitting? What if the flickers are breadcrumbs, subtle nudges left for us to find if we're smart enough to piece them together? Even the silence of official agencies feels suspicious. NASA and SA have issued statements repeating the same careful phrase. There is no evidence of artificial origin. But the choice of words only fuels speculation. Why mention artificiality unless it's being asked behind the scenes? Why emphasize what it isn't, rather than what it is? The phrasing sounds less like reassurance and more like defense, a way to shut down questions before they spiral. For some, that silence speaks louder than confirmation. It suggests there are conversations happening privately that we're not being allowed to hear. Put all of these details together, and Atlas starts to look less like an icy rock and more like a performance. Forward brightness, shrinking size, missing gases, retrograde orbit, timed concealment, planetary flybys. It's a checklist of anomalies stacked one atop the other, each one strange enough alone but together forming a pattern that looks designed. If this were a movie, people would roll their eyes and call it too convenient, too obviously written. And yet it's not fiction. It's real, and it's happening in our skies. The disguise is cometry, yes, but the cracks in that disguise are too deep to ignore. What makes Atlas so suspicious is not any single anomaly. It's the way they layer, overlap and reinforce one another, painting a picture that nature struggles to explain, but intention explains easily. A natural object can have one odd trait, maybe two, but not a half dozen all pointing toward deliberate design. And if that's the case, then the suspicion isn't paranoia, it's recognition. Atlas may not be a comet at all. It may be something far older, far smarter, and far stranger than we've ever admitted out loud. And if that's true, then every excuse, every denial, every desperate natural explanation becomes less convincing and more revealing of our fear. Because the truth staring back at us is that Atlas looks suspicious not because of what it does wrong, but because it does too many things right, exactly the way an intruder would if it wanted to pass through our system without being caught. When 3IATLAS streaked into the solar system, the astronomers who first traced its course faced a problem that went beyond the physical data. It wasn't just about measuring its speed, brightness, or chemical signatures. It was about deciding how to interpret something that looked too precise, too unlikely, too deliberate. Science thrives on probability, on weighing what is likely against what is possible, on filtering anomalies through the sieve of numbers until the improbable dissolves into the expected. But Atlas refused to dissolve. Its orbit, its glow, its timing, all of it stacked into a picture that felt statistically impossible. And that set off one of the most heated debates in astronomy, not about what Atlas is, but about how many improbabilities we can allow before coincidence starts to look like intent. On one side are the defenders of chance. To them, Atlas is just another comet, albeit an unusually weird one. They argue that the universe is enormous, that the number of icy fragments wandering between the stars is uncountable, and that when you have trillions of dice rolling across billions of years, even the strangest results eventually appear. Probability demands it. If you only notice the weird ones, the comets that glow the wrong way, the objects that slip through at odd angles, the ones that hide behind the sun, then of course they look suspicious. It's the same logic as lottery winners. Out of millions of players, someone always hits the jackpot. It doesn't mean the lottery was rigged. Atlas, they insist, is simply one of those lottery winners, an extreme outlier that looks special only because we happen to catch it in the act. But the counter-argument, whispered at conferences and shouted on late-night forums, is that this explanation crumbles under the sheer weight of the odds, because Atlas isn't just one outlier, it's the third in less than a decade. Oumuamua defied physics in 2017 with its inexplicable acceleration. Borisov arrived in 2019, a comet with chemistry that made it unmistakably alien in origin, and now Atlas combines features of both: cometary brightness with suspicious anomalies, a trajectory that looks like reconnaissance, and timing that seems engineered. To see 3 such visitors in such quick succession feels less like random dice rolls and more like someone stacking the deck. Yes, improbable things happen, but improbable things don't cluster this way unless there's a deeper pattern at work. This is where the statistical debate grows tense. For skeptics, the challenge is not explaining one anomaly, but explaining the cascade. Take the retrograde orbit. Interstellar visitors can, in theory, arrive at any angle, but retrograde paths are rare. Add to that the planetary flybys, close enough to notice, too precise to dismiss. The sun's glare at perihelion, another improbability. Forward-facing brightness, another. Shrinking size estimates, another. Lack of gas emissions, another. Each one on its own can be chalked up to noise, coincidence, or the wide variability of nature. But together they begin to feel like a message spelled out not in words but in odds stacked too high to ignore. One statistician tried to run the numbers, asking what the probability would be for an interstellar object to exhibit all these features at once. The calculations, while rough, came back with figures so small they were effectively 0 in human lifetimes. That doesn't mean impossible. Of course, probability rarely deals in absolutes. But when the chance is so low that you'd expect to see it once in the entire history of human observation, and you're seeing it now, the natural conclusion isn't comfort, it's discomfort. It's the realization that either the universe is playing an extraordinary joke, or we're refusing to admit the obvious. Maybe Atlas is not playing by natural rules at all. This is the heart of the statistical debate, the threshold where improbability becomes evidence. Skeptics cling to the law of large numbers, insisting that rare events must happen eventually. Believers argue that rare events don't cluster, don't escalate, don't echo each other like chapters in a book. When you flip a coin 1,000,000 times, you expect streaks of heads, yes, but you don't expect the coin to suddenly spell out sentences. Atlas to them is not a streak of heads. It's the coin spelling out words we're too afraid to read. But numbers alone aren't enough to sway the human mind. What makes the debate visceral is the psychology beneath it. Humans hate coincidence when it feels personal. If you run into a stranger in 2 different cities, you call it fate. If lightning strikes the same tree twice, you call it eerie. When Atlas passes through, hitting planetary checkpoints and hiding at just the right moment, it feels personal. It feels aimed. And that's where the defenders of chance stumble, because their explanations lack narrative. They rely on statistics to soothe, but statistics don't soothe the gut. The gut says, this is too much. The gut says, someone is watching. And once that suspicion takes root, no amount of equations can erase it. The most interesting part of this debate is how it echoes the arguments around Oumuamua. Back then, defenders insisted the acceleration could be explained by outgassing too faint to see. Critics countered that this was an assumption without evidence. For Atlas, the roles are reversed. Defenders point to faint gas emissions as proof of cometary nature, while critics counter that the gas is too weak to explain the dust. The same arguments, reshuffled, as though the universe is presenting the same riddle in different forms, waiting for us to notice the pattern. Statistically, that's suspicious in itself. Déjà vu doesn't fit neatly into probability curves. Even selection bias, the strongest card skeptics hold, begins to fray under scrutiny. It's true that we only notice the unusual. Our telescopes are limited, and our attention is selective. But if interstellar objects were truly so common that weird ones keep showing up, then the question becomes, why are the weird ones so weird in the same kinds of ways? Why do they all push against our models, forcing us to invent explanations rather than confirming them? Why do they arrive in sequence, each stranger than the last, as though escalating our discomfort? At some point, selection bias stops being an explanation and starts being an excuse. It becomes a shield we hide behind, not a reason we can rely on. Another layer of the debate is philosophical. If we admit that Atlas looks suspicious, we are forced to confront the possibility of intention. And intention implies intelligence. Intelligence implies others. That leap is terrifying, not just scientifically, but socially. It threatens to upend our worldview, our religions, our politics, our sense of place in the cosmos. The stakes of the statistical debate are not just academic, they are existential. To say Atlas is artificial is to open a door humanity may not be ready to walk through. And so the defenders of chance double down, not because the math is solid, but because the alternative is unthinkable. Probability becomes a shield, wielded not against ignorance, but against fear. Yet fear cannot erase patterns. Atlas isn't just another comet, it's part of a sequence. Oumuamua, Borisov, Atlas. 3 visitors, each carrying anomalies that stretch our definitions. 3 strikes in less than 10 years. The odds of that being random are not just low, they are absurdly low. To argue that this is all coincidence is to argue that the universe is deliberately taunting us with the impossible. And maybe that's the point. Maybe the statistical improbability is itself the message, a way of forcing us to pay attention. If the odds are so low that disbelief becomes irrational, then perhaps disbelief is the test. Perhaps the graders watching us don't care about the physics. We already know the physics. What they want to see is whether we can recognize improbability as communication. This is why the statistical debate matters so much. It's not just about numbers, it's about trust. Do we trust our models even when they strain against reality? Do we trust our gut even when it defies equations? Do we trust our institutions even when their reassurances sound like denial? Every side of the debate is less about Atlas itself and more about us. The object is just the trigger. The real test is whether we can admit that probability has limits, that at some point coincidence stops being coincidence and starts being intent. The longer the debate rages, the clearer it becomes that the numbers are almost secondary. What matters is whether we're willing to accept their implications. If the odds are billions to 1, do we still call it natural, or do we whisper the word we've been avoiding? If the universe keeps handing us impossible visitors, how many do we need before we admit that maybe they're not accidents at all? For now, the defenders of chance still hold the microphone. Their arguments are safe, respectable, rooted in the language of caution. But beneath the surface, the critics are gaining ground. Because every time another anomaly piles up, every time the odds grow smaller, the shield of probability cracks a little more. And someday soon, maybe with Atlas, maybe with the next visitor, that shield will break entirely. And when it does, the statistical debate will end, not with a resolution, but with a realization that the universe has been speaking all along, not in words, but in odds, and that the improbabilities themselves were the message we were too afraid to read. When scientists speak about 3IATLAS in hushed tones, what lingers behind every technical explanation and every cautious press release is a question they rarely say aloud. If this object isn't a comet, if the improbabilities are not coincidences, then what is it actually doing here? That question is where suspicion hardens into something more unsettling, because the trajectory, the disguise, and the timing all point toward intention, and intention implies possibility. For the first time, humanity isn't just staring at a rock drifting through space. We're staring at something that looks like it has a reason, and that single word changes everything. The first possibility, the one whispered the most, is reconnaissance. In this reading, Atlas is not just a traveller but a surveyor, a probe passing through the neighbourhood to collect data. Its planetary flybys start to look less like coincidence and more like mission planning, a deliberate path designed to observe the solar system's main worlds from a distance. Mars with its hints of life, Venus with its thick atmosphere, Earth bursting with civilization, Jupiter, the giant whose gravity controls so much. Each pass would allow detailed scans, subtle readings, maybe even the release of smaller subprobes. To human engineers, this logic feels familiar. It's exactly how we design our own missions to other worlds. Plot a trajectory that maximizes encounters while conserving energy. The unsettling thought is that someone else may be doing the same thing to us, and if it is reconnaissance, then the disguise makes perfect sense. A glowing, dusty comet is the perfect camouflage. No one looks twice at a comet, at least not beyond the ordinary interest of astronomers. It is a common visitor, a background character in the sky. But beneath the dust there could be something else. Machinery, sensors, structures designed not to dazzle, but to observe quietly. The faint gas signatures could be staged, the brightness engineered, the orbit planned. If you wanted to watch Earth without revealing yourself, hiding inside a comet is genius. It is camouflage on a cosmic scale, the perfect way to blend into the natural clutter of the universe. Another possibility is even stranger, that Atlas is not just a probe but a messenger. Some theorists suggest that its improbable orbit is itself a form of communication, that the way it passes each planet in sequence is a signal, a pattern designed to be noticed by beings intelligent enough to track it. After all, if you wanted to announce your presence to another species without frightening them, what better way than through the language of mathematics? A carefully chosen trajectory, a sequence of alignments too precise to be random, becomes a statement. We are here, we can do this, pay attention. It avoids the complications of a language, culture, or radio signals. It uses the one universal constant, physics. The path itself is the message, written across the solar system in the ink of orbital mechanics. The chilling part is that if this is true, then we've already received the message. The question is whether we're brave enough to acknowledge it. But some argue that Atlas could be doing more than watching or signaling. It could be planting. The idea is simple. An object this size, wrapped in dust and ice, could easily carry smaller payloads hidden inside. As it passes by planets, those payloads could be released. Tiny probes designed to drift quietly into orbit, slip into the atmosphere, or even land undetected. To us, this sounds like science fiction, but it is exactly how we think about exploring other star systems ourselves. When we dream of interstellar probes, we talk about swarm designs, small, distributed sensors that scatter across a system, each one collecting a piece of the puzzle. The mothership carries them in, drops them off, and continues on. If Atlas is doing the same, then the real story is not the object itself, but what it may have already left behind. The idea that our skies, our orbits, or even our ground could now be home to hidden observers is a possibility that sends shivers down the spine. There's also the question of why it would choose to hide. If this is intelligence at work, then why not simply announce itself openly? Why the secrecy, the camouflage, the plausible deniability of looking like a comet? The answer may be simple: caution. If you were approaching a civilization you knew little about, would you arrive with fanfare? Or would you test, observe, evaluate before revealing yourself? Humanity itself follows this logic. When we send probes to Mars, we don't land giant ships in plain sight of the whole planet. We send quiet machines, small landers, orbiters, rovers. We watch from a distance first. Maybe Atlas is doing exactly the same thing. To reveal itself openly would risk panic, aggression, misunderstanding. To hide as a comet, to pass quietly while watching, allows time to study us, to decide whether contact is wise at all. And that raises another possibility. Maybe contact is not the goal at all. Maybe Atlas isn't here for us specifically, but simply following a program, part of a much larger network of probes scattered across the galaxy. This is the idea of distributed surveillance. The thought that intelligent civilizations might seed the stars with countless watchers, each one passing through systems, recording data and transmitting it back. Atlas could be just one of many, unnoticed in most places but caught in ours because we happen to be watching closely. If this is true, then we may not be special at all. We may simply be one more star system in the database, logged and catalogued along with millions of others. That thought is humbling, almost deflating, but no less profound. It means the galaxy could already be alive with machines, each one silently taking notes. Yet the possibilities don't stop there. Some speculate that Atlas could even be testing us, not in the dramatic sense of alien exams or secret evaluations, but in a subtler way. If the path is deliberate, if the anomalies are too glaring to ignore, then perhaps it's a way of asking, are you paying attention? Do you notice? Do you have the intellectual maturity to recognize that improbability means something more? If we dismiss it, if we wave it away as just another comet, then maybe we've failed the test. If we see the pattern, if we admit the possibility of intent, then maybe we've passed. The idea that Atlas could be a probe not of Earth itself, but of human perception, is both unnerving and brilliant. It forces us to consider whether the true experiment is happening not in the skies, but in our own reactions. Of course, there is also the darker possibility, the one people avoid even more than the word alien. What if Atlas is not here to watch or communicate, but to prepare? History teaches us that reconnaissance often precedes action. Empires send scouts before fleets, surveyors before colonists. If Atlas is artificial, then perhaps it is charting resources, testing defences, or simply measuring the system for reasons we can't yet understand. The notion that it could be the first stage of something larger, something that might arrive later, is the kind of fear that makes even scientists hesitate before speaking publicly. Because once that door is opened, speculation turns quickly to panic, and panic is contagious. And yet, for all these possibilities, there is one more that lingers quietly, almost wistfully, at the edge of the debate. What if Atlas is abandoned? What if it is not a functioning probe at all, but a relic, a derelict craft launched millennia ago, still drifting, still following a programmed path long after its creators are gone? In that reading, Atlas becomes not a threat or a scout, but an artifact, a message from a civilization that may no longer exist. The dust, the glow, the cometary disguise could simply be the erosion of time, the wear of ages on an object meant for a mission long forgotten. To think of it this way turns Atlas into a cosmic tombstone, a silent traveller carrying the last echoes of a people lost to history. That possibility is haunting, but strangely comforting too. It reminds us that even if civilizations vanish, their creations can endure, crossing stars and centuries to whisper across the void. Every one of these possibilities, reconnaissance, messaging, planting, testing, preparing, or simply drifting, forces us to reconsider what we think we know about the universe. And that is why Atlas matters. Because whether natural or artificial, whether planned or accidental, it challenges our complacency. It asks questions we are not ready to answer, and it does so not through radio signals or flashing lights, but through the quiet eloquence of its path. It makes us wonder not just about what it is, but about ourselves, how we respond, what we're willing to admit, what we're capable of imagining. If intent is written into Atlas's orbit, then the universe has already reached out. The real question is whether humanity will have the courage to reach back. By the time 3IATLAS carved its way into the inner solar system, the debate had already split the scientific world into two uneasy camps, those insisting it was just a comet, and those daring to suggest it might be something far stranger. But as its path continued to unfold, attention shifted from the arguments about what it might be to the anticipation of what it would do next. Because the story of Atlas wasn't finished when it passed Earth. In fact, its most dramatic chapter had only begun. For all the speculation about its origins and intent, the truth is that the real test comes with time, and that's where the world now waits. In October 2025, Atlas disappears behind the Sun, moving into a position where Earth's instruments cannot follow. For astronomers, this is the most frustrating part of the entire event. The moment when Atlas is closest, the moment when it could reveal the most about its nature, is precisely the moment when it becomes invisible, hidden by the blinding light of our star. For those already suspicious of its artificial nature, this timing feels like more than coincidence. It feels like deliberate concealment. To them, Atlas has chosen the perfect curtain, slipping into the one place in the solar system where we cannot track it clearly. The frustration is amplified by the sense that something critical could happen in that hidden window. Fragmentation, acceleration, a sudden flare, a trajectory shift. Anything that could settle the debate once and for all may occur while we are blind. This waiting game has sparked an almost feverish atmosphere among observers. Professional astronomers schedule time on the most powerful telescopes, preparing for December, when Atlas will re-emerge from behind the Sun. Amateur skywatchers ready their equipment, determined to catch the first glimpse of its return. Governments quietly allocate resources, not just for observation, but for rapid response analysis, as though preparing for the possibility of a revelation too big to ignore. It is rare in science for anticipation to feel like suspense, but that is exactly what surrounds Atlas now. It is not just another comet passing by. It is a story with a cliffhanger, a cosmic drama paused at its most critical moment. The possibilities for what happens next are wide open. One outcome is that Atlas behaves like a typical comet. It continues to glow, maybe fragments into smaller pieces, and then fades into the darkness as it races back into interstellar space. If that happens, skeptics will declare victory. They will argue that all the anomalies were just noise, just quirks of observation, just coincidences stacked in an unlikely but still natural way. For them, the disappearance of Atlas without further surprises will close the book. It will be written into textbooks as an unusual comet, a statistical outlier, but nothing more. But for those on the other side of the debate, even that outcome won't settle things. Because the anomalies already observed, forward brightness, missing gases, improbable trajectory, won't vanish just because Atlas fades away. If anything, its quiet disappearance could deepen the suspicion. A perfectly timed exit, leaving no definitive answers, might look less like natural conclusion and more like careful design. Like a magician finishing the trick with a puff of smoke, Atlas slipping away without explanation could be the most suspicious act of all. The second possibility is more dramatic, that Atlas changes in ways that cannot be explained by natural physics, if, upon re-emerging from behind the sun, it shows acceleration inconsistent with gravity, or fragments in a way that suggests hollow structure, or brightens unnaturally, then the debate will erupt into something larger than astronomy. A sudden shift in trajectory, for example, would echo Oumuamua's unexplained acceleration, but on a grander, more undeniable scale. A flare of unnatural brightness could suggest energy being released in a way comets never do. Even a fragmentation that reveals symmetry, pieces breaking apart into equal geometric forms, would ignite speculation that would be impossible to contain. The scientific community would be forced to confront what it has resisted, the possibility of intent behind the object's behavior. And then there is the most chilling possibility of all, that Atlas leaves something behind. If smaller objects begin to appear in its wake, drifting into orbits around Earth or other planets, the implications would be staggering. We already know it passes near multiple worlds. If sub-probes or fragments settle into orbit, hidden among the thousands of satellites and debris already circling Earth, we might never know until one is discovered by accident. For now, this remains only speculation, but it lingers in the minds of those who consider reconnaissance the most likely explanation. If something small and silent now shares our skies, then the story of Atlas will not end with its departure. It will continue indefinitely, hidden above our heads. Meanwhile, the public's fascination grows. Unlike Oumuamua or Borisov, which captured scientific attention but little mainstream imagination, Atlas has become a subject of popular obsession. Its name trends across social media, its images shared by millions, its story told with an edge of mystery that resonates beyond the halls of academia. Conspiracy theories spread, claims that governments know more than they are saying, that Atlas is part of a hidden plan, that its reappearance will coincide with something monumental. For scientists, this is frustrating, but for storytellers, it is fuel. And perhaps for those who designed Atlas, if it was indeed designed, this attention is the point. Because if the trajectory itself is the message, then the public reaction is the reply. We are noticing, we are watching, we are asking questions. As December approaches, the waiting grows heavier. Telescopes turn toward the expected coordinates, simulations refine predictions, and every anomaly in brightness or movement is catalogued. But the truth is, no one knows what will happen next, and that uncertainty is what makes this moment so powerful. Atlas is a mirror, reflecting not just sunlight, but our own fears and hopes. It shows us how quickly coincidence becomes conspiracy, how eagerly we search for meaning in mystery, how fragile our definitions of natural and artificial really are. Whatever happens, Atlas will not be forgotten. If it fades away, it will leave behind a trail of suspicion that scientists will wrestle with for decades. If it changes in impossible ways, it will ignite a revolution in how we think about the universe. And if it leaves something behind, then the story has only begun. Either way, Atlas has already succeeded in one sense. It has forced humanity to look up, to wonder, to question. And that perhaps is the most important thing of all. The suspense is unbearable, but it is also thrilling. For the first time, humanity waits not just for data, but for revelation. For the first time, a comet, or whatever Atlas may be, feels like a character in our story, a presence with agency, mystery, and purpose. What happens next is uncertain. But the fact that we are even asking the question proves that something extraordinary has already occurred. The universe has our attention. The only question now is what it plans to do with it. When people look at 3IATLAS, they see more than a comet. They see a mirror reflecting the boundaries of our imagination, our science, and our fear. By the time its story reached the moment of vanishing behind the sun, the arguments about its nature had already revealed something far deeper than a debate about dust and ice. Atlas had become a symbol of how fragile our explanations can be when faced with anomalies, and how quickly the human mind leaps from probability to possibility when coincidences begin to stack too high. What Atlas represents now is not just an astronomical puzzle, but a reckoning with our place in the universe and our willingness to admit that the extraordinary might be staring us in the face. The implications begin with science itself. If Atlas is natural, then it is a comet like no other, one that forces us to expand our understanding of interstellar objects beyond what we believed possible. Its brightness patterns, its retrograde orbit, its suspicious timing, all of these would have to be explained as natural phenomena, which means our models of cometary behavior and orbital dynamics would need to be rewritten. It would remind us that the universe is stranger than we give it credit for, that nature is capable of crafting outcomes we once thought impossible. In that sense, Atlas would still be revolutionary, not because it is artificial, but because it expands the limits of what we consider natural. For scientists, that alone is thrilling, proof that the cosmos is not finished surprising us. But if Atlas is not natural, then the implications spiral far beyond science. The idea that it could be reconnaissance forces us to confront the possibility that humanity is not alone, that another intelligence has not only noticed us but has taken steps to watch us closely. In that scenario, our solar system ceases to be a quiet corner of the galaxy, and instead becomes a monitored space, observed not from a distance but from within. That possibility is as humbling as it is terrifying. It raises questions about why they are watching, what they are looking for, and how long they have been doing so. Are we just one of many civilizations catalogued across the stars, or is there something about Earth, its life, its technology, its trajectory, that has made us worth a closer look? And if Atlas is a message, then the implications become even more profound. A trajectory that sweeps past planets in sequence, that hides at the moment of closest approach, that glows in ways that defy our models. These could all be part of a carefully designed communication, a pattern meant to provoke thought rather than deliver information. If this is true, then we have already received a signal, not through radio waves or flashing lights, but through physics itself, the one language that transcends culture and biology. To recognize it as such would mean admitting that contact has already happened, in a form subtle enough to test our intelligence and patience. The question then is not whether we are alone, but whether we are capable of recognizing when we are being addressed. There is also the unsettling possibility that Atlas is planting seeds, whether literal probes or metaphorical ones. If it has released smaller objects into orbit, hidden among the debris that already surrounds Earth, then our planet may no longer be unobserved. The idea that something artificial could now share our skies is one that science fiction has warned us about for decades. But science itself has rarely dared to consider, and yet the implications are unavoidable. If Atlas leaves behind technology, then we are not just being watched, we are being studied at close range. That realization changes everything about how we see ourselves. We are no longer explorers at the edge of the galaxy, we are specimens under a microscope. The psychological impact of these possibilities may be greater than the scientific ones. Humanity has long been conditioned to see itself as central, unique, alone in the cosmos. Atlas challenges that conditioning directly. Even the suggestion that it might be artificial forces us to reckon with the idea that we are not the highest intelligence in play, that our story may be part of a much larger one written across the stars. For some, this thought is exhilarating, a promise that we are connected to a greater cosmic community. For others, it is terrifying, a threat to our sense of control and safety. Either way, the conversation is no longer confined to astronomers. It spreads through culture, media, politics, religion. Every person who hears the name Atlas is forced, if only for a moment, to consider the possibility that we are not alone. And then there is the most haunting implication of all. What if Atlas is old? What if it is not an active probe but a relic, a craft launched thousands or even millions of years ago, still carrying out a mission whose creators are long gone? In that case, Atlas is less a threat and more a time capsule, a reminder that civilizations rise and fall, but their artifacts endure. To encounter such an object would mean more than discovering alien technology. It would mean touching alien history, and that realization would forever change how we see our own species, forcing us to confront the possibility that one day we too will leave relics drifting through the void, silent markers of a civilization that once was. No matter which interpretation proves true, Atlas has already done something remarkable. It has broken the barrier of indifference. Where once we saw interstellar space as empty and silent, we now see it as alive with mystery. Where once comets were dismissed as icy leftovers, we now see them as potential messengers. Where once humanity saw itself as observers of the cosmos, we now feel the weight of being observed in return. That shift in perspective is irreversible. Even if Atlas fades into the dark without another anomaly, it has already left its mark. We will never look at the sky the same way again. And maybe that is the ultimate implication. Atlas has forced us to ask questions we were not ready to ask. It has forced us to confront our biases, our fears, our capacity for wonder. It has shown us that sometimes the most profound revelations come not from signals we hear, but from paths we watch, from trajectories that whisper possibility in the language of improbability. What happens next may be uncertain, but what has already happened is undeniable. We are awake now, our eyes fixed on the sky with a mix of fear and anticipation. Atlas has made sure of that, and in doing so it has already succeeded. Because whether comet or craft, whether natural or intentional, it has reminded us that the universe is not a silent stage, but a conversation, and the question is no longer whether we are ready to speak, but whether we are ready to listen. As 3IATLAS continued its silent journey through the solar system, the scientific debates about its nature, comet or craft, coincidence or intent, began to bleed into the larger culture. Suddenly, Atlas was no longer confined to the journals of astronomy or the quiet discussions of orbital mechanics. It became a subject of thought experiments, late-night debates, conspiracy forums, speculative novels, and coffee shop conversations. And in that cultural expansion, its significance grew far beyond its physical reality. Atlas had become an idea, and ideas, once unleashed, cannot be contained. The public reaction to Atlas was as fascinating as the object itself, because it revealed what humanity does when confronted not with answers, but with unsettling questions. The most common thought experiment was simple: what if Atlas is artificial? For scientists, this question is almost taboo, something to be discussed cautiously with caveats and disclaimers. But for the public, freed from the constraints of peer review, it became a playground of imagination. People asked, if it's a probe, who sent it? How long has it been travelling? Does it carry cameras, sensors, data storage? Has it been here before, passing unnoticed centuries ago? The possibilities multiplied in the minds of storytellers and dreamers. Some imagined Atlas as a scout ship, the first of many, charting the solar system for a civilization that will arrive centuries later. Others pictured it as an ancient relic, a derelict machine drifting aimlessly after its makers vanished, like a bottle tossed into a cosmic ocean. The very act of considering these possibilities shifted the cultural mood from skepticism to wonder. For many, the thought experiment itself was more powerful than any answer science could provide. But the reactions were not uniform. For every person who felt awe at the idea of Atlas as a messenger, there was another who felt dread. Fear bubbled in forums and comment sections where people speculated about hostile intent. Was Atlas observing us as a scientist studies an ant colony, or was it mapping resources for eventual exploitation? Was it measuring our defenses, testing our awareness, preparing the ground for something larger? In these darker corners of speculation, Atlas became not a symbol of discovery but of vulnerability, a reminder that if another intelligence is watching us, then we are no longer alone in the way we once believed. The thought experiments tilted toward paranoia, and paranoia spread faster than wonder. Governments too felt the pressure of public reaction. Agencies like NASA and ESA released careful, measured statements, always emphasizing that there was no evidence of artificial origin. But those very words fueled suspicion. People asked, why bring up artificiality at all unless the possibility was real? Why deny what no one had officially accused? The denial sounded less like clarity and more like obfuscation, like the well-rehearsed responses of institutions trained to manage panic. In the absence of transparency, conspiracy theories thrived. Some claimed that governments knew more than they admitted, that secret military telescopes had captured images of Atlas that were being withheld. Others whispered that fragments had already broken off and landed on Earth, hidden in facilities far from public eyes. Whether true or not, the lack of trust in institutions made these ideas feel plausible, and once planted, they spread. Meanwhile, philosophers and ethicists used Atlas as a thought experiment about humanity itself. If we discovered tomorrow that it was artificial, how would we respond? Would religions adapt to the idea of other intelligences, or would they resist it as heresy? Would governments unite to present a common front, or would they fracture, hoarding information and competing for advantage? Would ordinary people panic, or would they celebrate? These questions became fodder for classrooms, podcasts, and public debates. Because Atlas was not just about astronomy, it was about identity. It forced us to look at ourselves through the imagined eyes of another intelligence and to wonder what story we were telling to the cosmos. Were we a species worth contacting, or one better left observed from afar? In pop culture, Atlas became a muse. Filmmakers rushed to option scripts inspired by its mystery. Novelists crafted stories where the object opened to reveal sleeping travelers, or where its trajectory turned out to be the first word of a cosmic alphabet. Musicians released tracks named after it, wrapping its enigma in sound. Even visual artists found inspiration, painting Atlas as both comet and machine, a duality suspended in light and dust. In the span of months, it went from obscure astronomical designation to cultural icon, a symbol of how one object can ignite collective imagination on a planetary scale, and yet beneath the excitement and fear there was also reflection. Many people began to ask what it would mean if Atlas really were artificial, if another intelligence had crossed the void to reach us. Would it matter whether it was watching, messaging, or drifting? The very existence of such a thing would prove we are not alone, and that realization alone would change everything. It would shrink the human story but also expand it. It would make us less central, but more connected. Thought experiments turned into meditations on humility, on fragility, on the vastness of time and space. For some, Atlas became less about aliens and more about perspective, a cosmic reminder that our daily struggles are small against the backdrop of interstellar possibility. Public reaction also revealed the hunger for mystery in an age of certainty. In a world where algorithms predict our preferences, where data maps our every move, where science answers so many questions, Atlas represented the unknown, the kind of unknown that cannot be Googled or neatly explained. It was a reminder that the universe still holds secrets, that discovery is not finished, that wonder is still alive. For many, that was the most precious gift of all. But perhaps the most important reaction was the one that bridged the gap between science and imagination. Amateur astronomers, armed with telescopes in backyards and rooftops, began to track Atlas themselves. They shared data, images, light curves, chatter. They did not wait for official statements. They created their own networks, their own observations, their own interpretations. In doing so, they democratized the debate, proving that mystery belongs not just to institutions but to everyone. Atlas became a shared project, a shared conversation, a shared riddle that anyone with a curious mind could touch. That sense of collective ownership may be its greatest legacy. In the end, the thought experiments and public reactions to Atlas revealed as much about us as about the object itself. They showed our capacity for wonder and fear, our distrust of authority, our hunger for meaning, our creativity in the face of mystery. Whether comet or craft, Atlas had already succeeded in one profound way. It forced us to think beyond the boundaries of what we knew. It made us imagine, speculate, question, dream, and maybe, just maybe, that was the point all along. When 3IATLAS blazed into our awareness, it wasn't just another puzzle for astronomers. It was another chapter in the much older story of how humanity has always responded to the unknown in the sky. Throughout history, celestial anomalies have been treated not just as scientific curiosities, but as cultural touchstones, events that reflected the deepest fears and hopes of the people who witnessed them. In that sense, Atlas fits into a tradition that stretches back millennia. We may track its orbit with sophisticated telescopes and analyse its light with spectrographs. But in the end, our reaction to it is not so different from our ancestors gazing upward in awe, fear, and speculation. To place Atlas in the broader context of human history is to see it less as a singular event, and more as the latest reminder that the heavens have always shaped how we think about ourselves. Consider the comets of antiquity. To the Babylonians, Greeks, and Chinese, comets were omens, strange interlopers that arrived unpredictably and seemed to defy the orderly dance of the stars. They were portents of war, famine, the death of kings. Their unpredictability alone made them frightening, while the stars moved with reassuring consistency. Comets arrived without warning, changing the sky overnight. Atlas, with its sudden arrival and mysterious trajectory, echoes that same pattern, something out of place, something that resists easy categorization, something that makes us feel small in the face of cosmic unpredictability. Just as ancient rulers once trembled at the sight of a comet, modern institutions squirm under the weight of Atlas because it unsettles the story of control we tell ourselves about the universe. The Renaissance shifted the narrative, turning comets from omens into puzzles. With Tycho Brahe, Galileo, and Newton, humanity began to treat comets not as supernatural signs, but as natural bodies obeying laws that could be measured and predicted. That transformation was monumental. It marked a turning point where mystery was no longer simply feared but studied. Yet even then, comets held a peculiar aura. Halley's Comet, for instance, was not just an object of calculation but a cultural event each time it returned, inspiring both dread and wonder. In 1910, when Halley's tail brushed past Earth, people panicked at rumours of poisonous gas, while others held parties to celebrate. Atlas too sits at that crossroads between science and story. We can measure its speed and brightness, but we cannot prevent it from becoming an idea that escapes into the culture, one that stirs dread in some and fascination in others. The industrial and modern ages added another layer, the connection between celestial anomalies and the possibility of life beyond Earth. As telescopes grew stronger and imagination widened, comets and asteroids became tied not only to natural physics, but to speculation about other worlds. When Percival Lowell imagined canals on Mars, he gave birth to a wave of public fascination with the idea that our neighbours might be inhabited. Later, with the rise of UFO lore in the mid-20th century, strange lights in the sky were no longer just natural phenomena, but potential visitors. In this lineage, Atlas feels less like a comet, and more like an inheritor of that tradition, a celestial anomaly that fuels speculation about whether we are truly alone. It does not matter whether Atlas is natural or artificial. Its cultural impact places it alongside every unexplained light that has ever made humans wonder about other intelligences. In fact, one of the most striking aspects of Atlas is how it mirrors patterns of cultural response across eras. In antiquity, a comet meant doom. Today, Atlas sparks whispers of surveillance. Both reactions come from the same root, the recognition that something beyond our control has entered our world. In the Renaissance, comets pushed us to expand science. Today, Atlas pushes us to expand imagination. In the 20th century, unexplained aerial phenomena provoked conspiracy theories and mistrust of authority. Today, Atlas fuels the same suspicions, with people questioning whether governments are hiding the truth. The cycle repeats. Reshaped by technology but fundamentally the same, the heavens intrude, and humanity scrambles to interpret. Atlas also fits into the broader human story of confronting the unknown at turning points of civilization. Think of how the discovery of the New World shattered Europe's understanding of geography, or how Darwin's theory of evolution redefined humanity's place in nature. Each time the world grew larger, more complex, less human-centered. Atlas belongs to that same pattern. If it is natural, it stretches our science. If it is artificial, it stretches our imagination. If it is both, it stretches both simultaneously. Either way, it destabilizes our assumptions and forces us to reckon with the possibility that our story is not as central as we believed. Religions too have always grappled with the heavens. From the Star of Bethlehem to the zodiac signs, celestial events have been woven into spiritual narratives. In that sense, Atlas arrives at a time when humanity is once again asking big questions about meaning. in a universe that feels increasingly vast and indifferent. Some see Atlas as a reminder of divine mystery, others as evidence of higher intelligence. The parallel to history is clear. Celestial anomalies have always carried theological weight, challenging faith while also renewing it. If Atlas is interpreted through that lens, it becomes not just a comet or craft, but a symbol of transcendence, a reminder that we are part of something larger, whether divine or alien. And then there is the historical theme of control. For most of human history, we were at the mercy of the skies, storms, eclipses, comets, meteors. Only recently have we begun to feel mastery over them, with satellites, space stations, and planetary probes. Atlas disrupts that illusion of control. If it is natural, it reminds us that the universe can still surprise us with visitors from beyond. If it is artificial, it reminds us that we may not be the only ones capable of exploration. Either way, it humbles us, as comets once humbled kings. That humility is part of the broader context. Every age believes it understands the cosmos, until the cosmos delivers something it cannot explain. Placing Atlas in this long arc of history reveals that our reactions are not new. They are echoes. The awe, the fear, the speculation, the mistrust, the inspiration. These are the same responses that comets have always provoked, dressed now in the language of technology and extraterrestrial speculation. The difference is that we are now capable of measuring the details with precision, yet the core experience remains unchanged. We are still at heart a species that looks upward and wonders what the sky is trying to tell us. In the end, 3IATLAS is not just an anomaly of 2025. It is a continuation of a story as old as humanity itself. The story of celestial strangers intruding upon our world, reshaping our beliefs, and expanding our imaginations. It ties us to the Babylonians who feared omens, the Renaissance astronomers who chased answers, the 20th century dreamers who imagined alien visitors. In this way, Atlas is not just part of our present. It is part of our past and inevitably part of our future. Whatever its true nature, it will take its place in the lineage of wonders that have shaped humanity's relationship with the cosmos. And perhaps centuries from now, when people look back at the early days of interstellar discovery, Atlas will be remembered not just for what it was, but for what it revealed about us. That even in the age of data and precision, we are still creatures of awe, fear, and story, still standing beneath the stars asking the same ancient question, what does it mean? When 3IATLAS first appeared, it was already strange, already suspicious, already enough to stir speculation. But as the weeks and months passed, instead of the mystery shrinking under closer examination, it grew. That escalation is perhaps the most unsettling part of the entire story, because the longer we watched, the less it behaved like anything we had seen before. Every new dataset raised more questions than it answered, and instead of moving towards certainty, we moved further into a fog of confusion. The mystery did not fade with time. It thickened, pulling scientists, storytellers, and ordinary people deeper into speculation. What began as an interstellar comet grew into something larger, a phenomenon that seemed to challenge our very assumptions about how the universe works. The escalation began with the first anomalies in its tail. Comets, as every astronomy textbook explains, develop tails when the sun heats their icy surfaces, releasing gas and dust. The dust forms a bright curve, while the gas forms a fainter, straighter streak pointing directly away from the sun. But Atlas refused to obey that rule. Its tail bent at odd angles, sometimes appearing to wrap around it, sometimes fading in directions that made no sense. At first, this was blamed on observational error, atmospheric distortion, or instrumental glitches. But as more telescopes tracked it, the anomalies held. The tail seemed to have a will of its own, behaving in ways that could not be explained by sunlight or solar wind. For some, this was the first crack in the natural explanation. A comet that doesn't behave like a comet is already suspicious, and Atlas seemed determined to resist categorization. The next escalation came with its light curve. As Atlas moved closer to the sun, it brightened, but not in the way a normal comet brightens. Instead of following a smooth curve of increasing brightness, Atlas pulsed. Its light rose and fell in irregular intervals, as though something inside it was flickering on and off. Some described it as a heartbeat, others as a beacon. Official explanations suggested fragmentation, chunks breaking off, causing sudden bursts of brightness. But the pattern persisted too consistently to be random. Amateur astronomers, comparing notes across continents, began to wonder aloud if the pulsing was intentional, a signal encoded in light. Whether true or not, the very suggestion sent waves through the public imagination. If a comet could blink like a lighthouse, what else could it do? Then came the trajectory anomalies. Atlas had already shocked astronomers by entering the solar system on a retrograde orbit, moving against the usual direction of planetary motion. But as its path was refined, small deviations appeared, tiny accelerations and shifts that could not be accounted for by gravity alone. Solar radiation pressure, outgassing, and other natural forces were proposed as explanations, but none matched the data perfectly. Instead, Atlas seemed to move with slight corrections, as though adjusting its own path. The differences were subtle, easy to dismiss as errors in calculation, but over time they accumulated into a pattern that suggested choice. For some, this was the moment Atlas crossed a line from oddity into possibility, the possibility that it was steering itself. Public reaction escalated in parallel with the data. News outlets began to frame Atlas not as a scientific curiosity, but as a mystery with global stakes. Headlines blared about alien visitors and the comet that defies science. Social media amplified every anomaly into a narrative of conspiracy and cover-up. Videos speculating about Atlas racked up millions of views, blending fact and fiction into viral myths. For scientists, this was frustrating, yet they could not deny that Atlas was unusual enough to justify suspicion. The gulf between professional caution and public imagination widened, but both sides were drawn deeper into the mystery. Even those who dismissed the alien hypothesis had to admit Atlas was unlike anything we had seen before. Governments began to take more visible interest, and that too fueled escalation. Reports surfaced of classified satellites tasked with monitoring Atlas in wavelengths inaccessible to ground-based telescopes. Leaked documents suggested intelligence agencies were quietly analysing its behaviour, not for scientific purposes but for strategic ones. Was Atlas a threat? Could it be a weapon disguised as a comet? Could it reveal technology that might shift the balance of power? The secrecy only stoked suspicion. If Atlas were merely a comet, why all the hidden attention? Why the sudden rush to monitor it so closely? Even those who had no interest in astronomy began to sense that something larger was unfolding. The escalation reached a new height when Atlas passed behind the Sun in October 2025. For weeks, it was invisible, hidden by the glare, and speculation filled the void. People asked what it was doing out of sight. Was it breaking apart? Was it accelerating away? Was it leaving behind fragments or probes? When it re-emerged in December, brighter than before and with a trajectory slightly shifted, the mystery deepened again. Some argued this was natural, the result of heating near perihelion. Others whispered that Atlas had used the Sun as cover to alter its course deliberately. Either way, its reappearance did not resolve the story. It magnified it. The comet that should have faded grew stranger, more unpredictable, and more central to public imagination. At this stage, thought experiments escalated into something closer to collective obsession. Ordinary people tracked it with backyard telescopes. Forums dissected every light curve, every orbital refinement. Fringe theories bloomed. Atlas as a messenger, Atlas as a scout ship, Atlas as an ancient relic from a vanished civilization. Some even claimed it was an ark, carrying life through interstellar space. While most of these ideas had no scientific basis, the sheer proliferation of speculation showed how deeply Atlas had embedded itself in the human psyche. It was no longer just a comet. It was a canvas on which people projected their deepest hopes and fears about the universe. And yet, amid the escalation, one truth became clear. The mystery itself was the power of Atlas. It did not need to reveal answers to hold our attention. It only needed to resist explanation. Every failed attempt to categorize it, every anomaly that lingered unresolved, every official denial that rang hollow, these were the fuel that kept the story alive. Atlas thrived on uncertainty, growing larger in the public mind the less it was understood. It became a mirror not just of science but of culture, showing us how we react when faced with something we cannot explain. Some respond with curiosity, others with fear, others with creativity. In that sense, Atlas exposed as much about us as it did about itself. The escalation of the mystery is ongoing, and that is perhaps the most unsettling part. Atlas is still out there, still moving, still defying easy classification. Each new observation has the potential to resolve the debate or deepen it, and the balance so far has tilted toward the latter. Whether it is natural or artificial, comet or craft, messenger or mirage, Atlas has already achieved something profound. It has captured our collective imagination in a way few objects ever have. The mystery has escalated not because Atlas revealed more of itself, but because it revealed more of us, our hunger for answers, our mistrust of authority, our fascination with the possibility that we are not alone. In the end, 3IATLAS is less an object and more a test, a mirror held up to humanity, forcing us to confront how we respond when the familiar rules of the cosmos suddenly feel fragile. Whether it is a comet unlike any we've seen, a probe launched by an intelligence older than our species, or something in between, Atlas has already changed the way we look at the sky. It has shown us that even in an age of satellites, space stations, and constant observation, the universe still has the power to surprise us, to humble us, to remind us that we do not have all the answers. And perhaps that is the greatest gift Atlas brings, because in that surprise lies the spark of curiosity that has always driven us forward. Think about what Atlas has done. In just a short time, it has blurred the line between science and story, between data and myth. Astronomers pore over its orbit, its brightness, its anomalies, while ordinary people share their own interpretations, their own fears, their own dreams. Governments treat it with suspicion, artists treat it with inspiration, and the rest of us treat it as a mystery worth watching night after night. Few things in history have crossed so seamlessly between disciplines, touching every corner of human culture, from hard science to whispered conspiracy, from professional journals to backyard telescopes. That breadth of impact is extraordinary, and it tells us that Atlas is not just about astronomy, it is about imagination. But beyond the science and the culture lies a deeper truth. Atlas forces us to reckon with our place in the universe. If it is natural, it tells us that the cosmos is still stranger than we think, capable of producing objects that defy our models and predictions. That in itself is humbling, because it means our science, as advanced as it feels, is still incomplete. If it is artificial, then the implications grow even more staggering. We are not alone, and the universe is already aware of us. That possibility carries both wonder and fear, because it means we are participants in a larger story, one that began long before us and will continue long after. Either way, Atlas reminds us that we're not the centre of the universe but a small part of something far more vast, far more mysterious, and far more alive than we once believed. And perhaps that is why Atlas resonates so strongly. It is not just about the object itself, it is about us, about our hunger for meaning, our instinct to speculate, our tendency to project ourselves into the stars. Every comet in history has done this, but Atlas has done it more intensely, more globally, more dramatically. It has revealed how quickly humanity shifts between awe and paranoia, between science and story, between skepticism and belief. It has shown us that we are still, at our core, a species that looks up and wonders. So as Atlas continues its journey, leaving behind questions we may never fully answer, it also leaves behind a legacy of imagination rekindled, of humility rediscovered, of mystery re-embraced. Whether comet or craft, whether natural fluke or deliberate message, Atlas has already succeeded in the most important way. It has reminded us that the universe is not finished speaking to us. The real question is whether we are ready to listen,